Okay, now what about the last one here for rationalizing? What do we have to multiply by?
5.
Square root 5. And we're going to multiply that on top and bottom. So on top, root 3 times root 5, root 15. And on the bottom, root 5 times root 5, root 25, which is 5. Okay, so on your assignment tonight, the first, I think it's like 10, 12, are going to be like last night, where you're just simplifying the square root. The last 6 are going to be like these two, where you have to rationalize. And that's because when we start with special triangles here, we have a lot of this that starts to happen. Yeah.
Are you able to solve that further?
No. Okay, so any questions about simplifying square roots or rationalizing the denominator? All right, on to Pythagorean theorem. So you guys said you had seen this before. Most people raised their hands. So what is it?
A squared plus b squared equals c squared.
Well, that's great, but what is the Pythagorean theorem?
You're trying to find the
missing
I forgot what the line's called, but you're trying to find the diagonal line, right? Trying to find the biggest side usually. That
Okay, which one's the hypotenuse?
one diagonally across from the right angle.
It's across from the right angle. It's called the hypotenuse. I also heard someone say it's the longest side. It's also known as C in the Pythagorean theorem. What's A?
It's one of the legs.
It's a leg. It's one of the legs. And what's B?
The other leg.
The other leg. All right, so we're going to be looking at the Pythagorean theorem in two different ways. The first way we're going to look at it, we're almost done, is to find a missing side of a triangle. That missing side will not always be the hypotenuse. It can sometimes be a leg. So how can we use the Pythagorean theorem here to solve for x?
A squared plus 13 squared equals x.
Squared. Okay, so what is 8 squared?
64.
13 squared?
169.
169. What's 64 plus 169?
I don't know.
233. And then how do we solve for x?
Yeah.
We square root both sides, which is why we did that whole bit on square roots. So what is the square root of 233? This is where reading the directions is going to tell you what to do. If it says to leave it in radical form, leave it in radical form, meaning you just look to see factor tree, does it work? Can you break it down any further? This one you can't, so we would just leave it as root 233. If it says decimal form to the nearest tenth, then you can punch it into your calculator and you would get about 15.3. So reading the directions is going to tell you how to give your answer, whether it's a decimal or a radical. So please read the directions. Okay, so this is the first way that you're using the Pythagorean theorem, just to solve for a missing side. Any questions on that? Okay, the second way that you're going to be asked to use the Pythagorean theorem is it's going to ask you, is a triangle with sides (20, 21, and 29) right? In other words, is it a right triangle? So when you're trying to figure out whether or not something is a right triangle, it has to fit the Pythagorean theorem. So what we're going to do is plug these numbers into the Pythagorean theorem to see if they actually give us an equal equation. So this is where knowing where the longest side goes is going to be important. So which one's the longest side?
29.
What letter is that going to correspond to? C. So we're going to say A, B, C. 20 squared plus 21 squared equals 29 squared. We're going to test, is this true or not? Let's see, what's 200 squared? 400. What's 221 squared? 441. And 289 squared? Or sorry, not 289, 29 squared.
Yeah, I don't know.
841.
841. So when we add the left side together, we get 841. Does that equal 841? Yes. So we have a right triangle. If you were to add these together and it did not equal the right side, then you would say it's not a right triangle. It's actually would be acute or obtuse, depending on whether it's smaller or larger. Okay, so these are the two main ways that you're going to be using the Pythagorean theorem. To find a missing side and to tell whether or not you have a triangle or a right triangle. So any questions on the two ways that you're going to have to use the Pythagorean theorem tonight? Okay, I do want to do one more with you, and that's a word problem.
Dang it. Hey, words.
Words are awesome though.
Not in writing. I like better when it's spoken.
All right, a 13-foot ladder is against a tree. If the base of the ladder is 5 feet from the tree, how tall is the tree? You get it?
Yeah, I think. Because 13 would be C, right? And you have to go back through and solve for B, which would be like the height of the tree. Yeah.
Okay, do you want us to tell us what you're seeing in your head? Because I don't know what you're seeing.
Okay, I'm seeing like just a regular triangle, and the hypotenuse is the tree against the tree. It's a ladder against it, and then I see the bottom leg, like
So ladder.
the horizontal one.
Uh-huh.
I see that as like 5 feet away from the tree, and then we have to solve for like the tall one, which is the tree.
Okay. So with these, draw out what you see. So that way we can kind of all be in the same page. So here we have a tree, and we're going to make the assumption that our tree is going straight up out of the ground, not leaning to one side or another. You have the ladder that's leaning up against it. From the distance between the tree and the base of the ladder is 5 feet. How tall is the tree? So here's an example of one where we're not solving for the hypotenuse. So how do we solve it?
C squared plus B squared equals X squared.
Set it up the same way. So what's our C squared? Or what's our C? 13. So we'll have 13 squared. That has to go by itself. Then we're going to add the other two. X squared plus 5 squared. So we have our leg squared plus leg squared equals hypotenuse squared. So x squared plus 25 equals 169. Minus 25 to both sides, we get 144. So x is 12. So that means we have a tree that is 12 feet tall. Okay, any questions on the Pythagorean theorem or square roots, radicals?